Ajá. Okay. You see whiteboard, right?
Yes.
Now, okay, this is quadratic function. What is the glue? Give me information. The quadratic. This is exponent 2. Exponent 2 quadratic, right? Parabola. And this parabola, okay. This parabola is expressed in standard or in vertex form. Standard or vertex form. I suppose que standard, right? Standard, remember, is when it is ax squared plus bx plus c, ¿no? It's a function. En this case no x es pi, pero es the same. Entonces es obvio que a es -4, b es 4000, and c es 0, es missing. We have no the constant part. Entonces this parabola, this is the parabola actually. In what direction open? Upward or downward? In what direction?
Downward.
How do you know?
Because the a is negative.
Absolutely perfect, because a is negative. So this parabola open downward because she said a is negative. This is the key to understand this. And it's obvious also que the revenue is maximum in the vertex. In conclusion, the only thing that you should do is compute the vertex. The vertex, remember, is h, k, no? H represents the x component, que the x component in this word problem is P. It's a price in dollar. And K is the revenue, que is a Y component. And dollar also. This case is a coincidence. Not always happen, but in this case it's dollar. So now, to find the vertex, we're using the formulas. H is equal minus B over 2A. Minus B is 4,000 divided by 2 times -4. I can see, be careful, the signs, double negative together is positive. 2 times 4 is 8. Entonces 4,000 divided by 8 is $500. Okay, this is the price of this equipment, no? Is the clothes dryer. If you want to find revenue that you get when you sell this product and this price, so this is the price of the only one gas clothes dryer. You want to find revenue, well, you plug it in. Revenue at 500 is equal -4, 500 squared plus 4,000 multiplication by 500. Okay, you put in a calculator, it doesn't matter. The arithmetic is not important, it's $1 million. 1 million. Okay, everyone understand this problem or no? ¿Es easy o complicated?
Understood.
Excellent. Let's move on to another, similar. May I erase the board? Erase? May I?
Yes.
Yes.
Okay, let's move on to the second problem. Second problem is a little bit similar, but no, something is different. Look, here's the second. Okay, this is the second. The second is about the marginal cost. The marginal cost in dollar of manufacturing X cell phone in thousands is given by this formula. So this is the formula for the cost. Cost is bad for the manufacturer, ¿no? Entonces es obvio que the cost in any manufacturer need to minimize. Entonces the formula is 5 x squared minus 200, x plus 4,000. This is the formula that states the relationship in between x, que represent the number of cell phone in thousands. So when the x is 1, actually we have 1,000 phones, okay? And the information is given is cost in dollars. Okay, entonces my question, the question say, how many cell phones should be manufactured to minimize the marginal cost? Okay, minimization. And second is what is the minimum cost, marginal cost. Okay, 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 no problem. I understand very well. Entonces now, this is also parabola, yes or no? Because it's quadratic wedge. Look at that. These two indicate also is quadratic wedge. And this is expressed in standard, no? F standard, we study f of x is equal ax squared plus bx plus c. Entonces, AFI, b es negative 200, and c is 4,000. This is 0, 4,000. Entonces, this is the parabola. Pero in what direction open this parabola? Open up or open down?
Up.
Up. Because in this case, the A is positive. This is the only parameter that controls the direction, guys. And I need to find the minimum that always happen, occur in the vertex, h, k. Likewise, you need to find h. H represents the x component, and the x component in our word problem represent the number of the cell phone in thousands. And k represent the cost. Okay, I need to minimize. Okay, entonces the same formula. H is equal minus b over 2a. Minus b is negative 200, yeah. 2AFI. 2 times 5 is 10. Be careful with the sign. Double negative become positive. It's 20. It's 20 because 200 divided by 10 is 20. No? 20 what? 20,000 actually of the cell phone. So this answer we can interpret it like actually 20,000 phones. Okay, it's 20, but the formula we divide by thousands. So you omit 30. You in your mind you omit 30. Now K represents the cost, the minimum cost. Is evaluate the function in 20, que is 5, 20 squared minus 200 times 20 plus 4,000. You put in the calculator and the answer is 2,000. 2,000 is the cost. Not bad. It's a minimum. Minimum cost when you manufacture 20,000 phones. Okay. Clear or confusing? Clear or confusing? No.
I have a question.
Go ahead.
Wouldn't the 2 and the 5 become negative as well? So
No. A is positive. Look, A is positive 5. Look at that. Entonces, and the formula have a minus here. Chun chun. But the only negative is B. And negative and negative together is positive. Is clear?
yes, thank you. I thought the whole thing was negative. Thank you.
No. Okay. Now, today we start new sections. New section que is about introduction to polynomial functions. Introduction. This is D, no? Introduction, and this is important word, capitalization, polynomial function. Very well. Okay. Definition first. Definition. Polynomial is easy to understand because polynomial is a collection of monomial. In this case, we are using only one variable, only one, is x, no x, y, z, no, only one variable. And the most important to visualize the polynomial is that the exponent and the polynomial always are, so the exponents are whole number. What means whole numbers? Whole number means 0, 1, 2, 3, 4, 5. Okay, the example for the polynomial, suppose f of x equal 4 x to the 5th power plus 6 x to the 4th power plus 2x. This is the exponent of 5, 4, and 1 here. Okay, 1, you know, is invisible. This is the polynomial, of course. By the way, degree of 5, because degree is by definition the highest exponent, degree 5. Okay, suppose example, no polynomial. This is poly is okay. Okay, this is no okay. Exponent fraction, suppose we have 4 x to the 3 over 4 plus 6 x to the 4th power plus 2x, no poly, because exponent fraction is completely out the definition. And exponent negative number is also out the definition. Suppose 4x to the 5th power is okay so far. 6x to the minus 4, no polynomial, plus 2x. No polynomial. Okay? And when it's polynomial, when it's yes, like this, you can see now that the graph is super nice. The graph is totally continuous, always continuous. Continuous means that we have no hole, we have no gap. Is in few words, one function is continuous when you are doing the graph without lifting the pencil from the paper. Continuous, it's smooth. It's smooth because we have, it's something like that. We have, for example, a sharper point like that, no corner like that, no corner, no cups like that, no. It's completely smooth. Okay. Now, the first thing you need to understand in the polynomial function is the end behavior. Let me explain in detail this idea. End behavior. End behavior. Okay, end behavior is, let's come back again to this. F of x is equal minus 4x to the 5th power plus 6x to the 4th power plus 2x. Suppose this is a polynomial. because the exponent is 5, 4, and 1. Nice. Now, the end behavior represents the dominant term. And dominant is the term que increasing faster. And it's obvious que the term que increasing faster is this, because the exponent is 5, and the exponent 5 increasing super faster than 4 and 1. So the end behavior expression is end behavior expression is negative 4 x to the 5th power. End behavior expression. So one way to visualize this is, look, in this case the exponent is odd number. So exponent is odd number, and the coefficient, okay, the number in the front, is negative. And when this situation happens, the graph look like that. I don't care exactly what happened in the middle. The middle is not important. This part is not important. The end behavior is, you see, for example, left up. Another way to visualize in words, left, up, and right down. See, the exponent is also odd, but the coefficient is positive. Well, it's completely opposite. It's like that. It's right up and left down. If the exponent is even, is even number, suppose 2, 4, 6. The exponent for the dominant, we are talking about dominant. The rest, for the end behavior, I don't care. And coefficient is also positive. It's a plus. Entonces, something like that. Like a quadratic function, ¿no? In quadratic function, remember, the exponent is even, because the quadratic, the exponent is 2. The end behavior is 2. Entonces, right up and left up. Okay, the last one is also exponent even. And coefficient is negative. And coefficient is, sorry, negative. Entonces, like that. The classical example is the quadratic function, ¿no? Pero no necesarily si the problem is more complicated, so we have more situation here. Okay, after we analyze in detail. Entonces, this is right up, down, and left also down. Okay, let's practice a little bit. I give you example, and you please try to classify the polynomial according to the end behavior. For example, this example number 1 is f of x is equal x to the cubic power plus x to the second power minus 9x minus 9. Okay, first question is, this is polynomial, yes or no? Oh, yes, because the exponent is 3, 2, 1, and 0. By the way, this is 1, and this is 0, because we have no x. So, you know, any expression or number raised to the 0 power is 1. So the degree is obvious 3. The end behavior expression is x cubic. Oh, yeah, I know very well the x cubic graph look like that. Like that. Actually, it's like that. X cubic. In other examples, it's different, but this is like that. Entonces, the end behavior graph is right up and left down. Okay, this is easy. Another way to visualize this is look when the x, because end behavior relates somehow with the infinity, no? This is end behavior. When the approach to positive infinity, or when the x approaches to negative infinity. Okay, positive infinity is in this direction. Negative infinity is in this direction. So what happened with the y value? Y value approaches to positive infinity also. That is the reason case right up. And other hands, when it approaches to the negative infinity, case left. Negative infinity is left. And y approaches to negative infinity. But not necessarily it's the same always, no? Dependency, you know. But it's another mathematical, symbolic way to indicate end behavior, right? Or graphically, or in letter, left down, up, or this one. That was example 1, easy. Example 2, it's not easy. It's more complicated. It's all confusing. Example 2. Example 2 is the function is g. It's a polynomial also. 1 over 4x. 2x minus 3 cubic. X plus 4 squared. Okay. Unfortunately, or fortunately, I don't know. This polynomial is expressed in factory form. So somebody know me, do the factorization. Entonces, when it's factory form, it's a little bit more complicated to see the degree, but it's okay. Let's try. And the end behavior. Okay. What do you suppose que es the degree? A ver, opinion. I need opinion of this polynomial. What's the degree? Remember, what is the definition degree? Degree is when you write the polynomial, you take the higher exponent, no? Pero when you expand, no factor form. Entonces, that is the reason it's confusing, no? Do you see what's the degree? Let me change a little bit. Let me change a little bit the question. The question is, what is the end behavior expression? In this case. Because you take always end behavior expression, you take the monomial, no? And the collection of the monomial and the polynomial, you take the higher exponent and the end behavior expression. A ver, opinion, degree and end behavior expression. What do you think? No idea, totally lost. Opinion, dale, go ahead.
Is it negative? Is it 3?
No, it's not 3. It's confusing, I know, it's not 3. And what do you think when you expand, you foil this binomial, this binomial, this binomial together, and you expand? What is the expression can contain the higher degree? Okay, let me focus the question in different order. End behavior expression. End behavior expression, remember, it's when the x approaches to infinity, positive or infinity, negative, in both directions, no? Entonces, when you plug it in, what means infinity positive or infinity negative? Infinity positive is one super big number, million, trillion, here. Entonces es obvio it's obvious that 3, negative 3, and positive 4 here is completely negligible. So my expression look like that. 1 over 4, x stay, no problema. 2x cubic, and x squared. Something like that. Do you understand the idea? This number, negative 3 and positive 4, is nothing when you're talking about big number, right? Now you multiplication. This is 1 over 4 x, and this is 2 to the cubic power is 8 x squared, x cubic, sorry, and x squared. Entonces in total we have, well, 8 divided by 4 is 2. And how many x do we have in total? 1, 3, 2 is 6, right? This is the mean behavior expression. Wow. Entonces now you see clear now. What is the degree of this polynomial?
6.
Absolutely perfect. Another way to see clear, you see 1 plus 3 plus 2. Because I can guarantee you 100% that when you expand, not in factory force, you expand, you get one polynomial star and 2x to the 6th power plus something I don't know now. I can do that, but it's too long. Clear or confusing?
Clear.
Another important thing, may I erase the board?
Yes.
Okay. Okay, another important, super important, extremely important is the zero. Identify zeros. And multiplicity. Wow, what the hell is that? Multiplicity of zero. This example. Example 1 of the identification or identify zeros and multiplicity. Suppose. F of x is equal x cubed plus x squared minus 9x minus 9. Okay, entonces identify the zero means que you enforce the function equal to 0. It's the same idea that we discussed before. It's fine. Basically, you need to find, when you're talking about 0, 0 is the x-intercept. So it's the point when the polynomial function crosses the x-axis. And when you find the x-intercept, it's a 0, the real 0. Okay, it's the real 0, Now, let's do it. In this case, super easy. I want to using the elementary idea for the factorization. Okay, the factorization is good, but it's weak. Okay, entonces I analyze this couple and that couple. This is factorization by grouping, no? Okay, you know very well. The gray common factor in the red couple is x squared. Entonces x plus 1. The gray common factor in the blue couple is negative 9. It's x plus 1. I see que x plus 1 again is a common factor. Entonces we have x plus 1 factor out one more time, x squared minus 9. I finished the factorization? No, because I saw here a differences of a square. X plus 1, paréntesis, is xx 3 plus or minus. Entonces now you separate, when you fight to complete the polynomial, okay, nice, you separate one by one, x plus 1 equals 0, zero factor property, or x plus 3 equals 0, or x minus 3 equals 0. And you solve it one by one separately. This is negative 1, It's a -3, and it's a +3. Entonces listing the zero. Well, okay, the zeros of this polynomial are x equal -1, x equal -3, and x equal +3. This is the zeros and the factors. It's important concept you need to be clear. The factors that we have in this polynomial is x plus 1, x plus 3, and x minus 3. Super easy. And the multiplicity. What means multiplicity? When the 1, 0 is not repeated, it's unique. -1 is only 1. -3 is only 1. And +3 is only 1. Entonces es not repeated. That means the multiplicity is 1. And when the situation happens, when the multiplicity m is odd number, the graph cross the x-axis. Let me try to get a rough idea. See, multiplicity is even number. The graph touch the x-axis. This is super important. In this case, no. In this example, no. In the next example, yes. But in this example, no. We have no multiplicity even because the exponent is, look, 1, 1, and 1. Nice. So you, for example, you have to get a roughly idea, okay, roughly idea by hand, and after using decimals, what is approximately the graph of this polynomial? Let's do it. Or let's do roughly idea. Okay, -1 here, -1, -1, -3. Oh, espérate, no good. Again. Okay. XY is -1 here, -3, -2, -3 here, and +3 here. Okay, this is a 0. Okay, that point is 3,0, obviously, no? -1,0 and -3,0 because the supposition was that the y is 0. That is the reason que es x in a set. However, I know that the end behavior expression is x cubic, and this case was easy. See that because there's no factor 4, and the end behavior graphically look like that. Okay, because the exponent is odd and the coefficient is positive. So the end behavior look like that, Entonces my graph approximately, no exactly, is something like that. End behavior give me this information. Entonces the rest in the middle, I have no idea. Depending the 0. Depending the y in a set. Okay, by the way, the y in a set is in 9. At that point is the point 0,9. Okay. But let's see now in decimals. I solving any problem by hand and decimal, no? Decimal is like a verification, double checking that we are doing well. Or see I make a mistake, well, I fix it. Okay, let me, do you have questions? Do you understand like the idea? This elementary example, no, number 1? Okay.
Are the zeros always going to be like, all of them are going to be either negative or positive? I mean, odd or positive, or even.
Yeah, all real number. They are positive, negative, 0, yeah. And you see after we see imaginary and complex, but no now. So far, real. Positive or negative, no restrictions. This is your question, miss? Oh no.
Like if they're always gonna be like even or odd. That's what I meant to say. Like ask.
Pero the multiplicity.
Yeah, yes.
Bueno, in this case, the multiplicity is 1. Entonces, when the multiplicity is 1, you see that the graph, look, let me show you. The graph crosses the axis. Look, crossing means this. Cross it, and cross it. And you see another example, example number 2, que no cross it, touch it. Pero no, wait, relax. Let's see this graph in detail in Desmos. Now. Okay, let me share a screen switching to Desmos. Wow, no good. Do you see Desmos? Yes or no?
Yes.
Okay, this is my first example, look. And this is the graph. Boom. Look at that. Oh, more clear now. The 0 is the point in which the graph crosses the x-axis. In 3,0, negative 1,0, negative 3,0, this is the x-intercept, que is also zeros of the polynomial. And the y-intercept is 0,9, and the aim behavior, you know, wow, look like exactly like a right up and left down, because the aim behavior expression, que es x cubed, the exponent is odd number, and also the exponent is odd number and the coefficient is positive, no? This is the reason. More clear now? A little bit, not totally, but a little bit. More clear? No?
Yes.
Okay. Is no Chinese? Go ahead. Question.
Oh no, I'm just saying it's clear, Profe. Thank you.
No problem. Now let's move on to example 2. In the example 2, you see when it touch, and we study everything together and behavior, something. Example 2 now. Example 2. In example 2, you have f of x. Let me see. Okay. In example 2, we have the polynomial x to the 4th power minus 4x to the 2nd power. Okay. Entonces now en behavior expression is x to the 4th power. Entonces the exponent is even. Therefore, I suppose, and coefficient is positive, I suppose that a in behavior look like that. Yes or no? In the middle, I have no idea. It's right up and left up. This is the a in behavior. The zeros. Now, the 0 is you enforce it, the polynomial equals 0. Nice. And you try to do your best doing the factorization. The factorization is, well, great common factor is x squared minus 4. I continue factorization because I see x squared is a difference of a square here is xx to 2, plus or minus. You have completed factorization, our polynomial. I separate each factors equal to 0, or x plus 2 equal to 0, or x minus 2 equal to 0. Entonces you see que x is 0. It doesn't matter que the exponent is 2, because when you find square root both sides, so because x is 0, the square root 0 is 0. But the multiplicity is 2. So actually, so you count how many 0 we have in this. Well, I forgot to say that the degree of this polynomial is 4, no? So now, when you finish, the number of 0 is coincident always with the degree of the polynomial. Then we have 4 zeros. We have 0, pero 2 times, because the multiplicity 2 times, negative 2, multiplicity 1, one time, and positive 2, sorry, multiplicity 1. So si I summarize the zeros of this polynomial, we have 4. Is x equals 0, multiplicity 2, x equal minus 2, multiplicity 1, and x equal positive 2, multiplicity 1. In total, 1 plus 1 is 2, and 2 plus 2 is 4 zeros. And the factors is x squared, x plus 2, and x minus 2. Entonces, the new thing that bring me this situation que multiplicity is 2 is because when the multiplicity is 2, let me try to do my graph by hand. Okay. Bueno, de 0 es en 0, en 2 y en negativo. Entonces, the graph and the main behavior, I know can look like that. Look at that part. Don't forget this, important. The graph is coming from this. Here is a 0. But this 0 que es en positive 2 cross. How do you know que cross it? Because the multiplicity is 1. When the multiplicity is odd number, cross it. When the multiplicity is cross number, this cross it and this cross it. But this no, it's touch. Entonces the graph, I suppose, can look like that. Look, touch, and now cross, and continue here. This is my roughly sketch of the, this is 2, this is 0, this is negative 2. Do you understand or no? Yes or no?
For the part where you have x equals negative 2, m equals 1, did you bring the 2 to the other side? Is that how you got like negative 2?
I don't understand your question.
Where it says x plus 2 equals 0 on the bottom. Like if you brought the 2's to the other side.
Bottom. What is the bottom?
Like where it says or x plus 2.
Okay. Okay. I don't understand very well your question, but I suppose que the question is about what is the reason que I separate this in 3 pieces, no? Or no?
No, like if you brought the 2, like x plus 2, if you did minus 2, and that's how you got x equals negative 2.
Because the reason is when you have, no, you have this equation. How you solve this equation, you move 2 to the right hand side like a minus 2, no? This equation?
Yeah, thank you.
Okay. Entonces, any question, how look like? The most important, that part I suppose that you know. The new part is determine the 0 using factorization so far, and the behavior to say in the somehow way of the zeros. So when the multiplicity of the zeros. So how many zeros in total we have in this polynomial? Well, actually we have 4. So you listing this 0 is 0, 0, negative 2, positive 2. A 0 have multiplicity 2. However, the rest no. Multiplicity 1. Multiplicity indicate repetition. And then when the multiplicity is even number, the graph touch the x-axis. Somehow. When the multiplicity is odd, maybe 1, maybe 3, maybe 5, cross. This clear, this idea? This is important idea. The rest is cosmetic, algebra, intermediate algebra, que si you isolate. No. Okay? Got it? Let me see in decimals. This example 2 in decimals to understand much better. Okay. Do you see decimals? now or no? Do you see decimal now or no? Yes or no?
Yes.
Yes, profe.
Example 2, look at that. Boom. Is our graph of that polynomial que es x to the 4th power minus 4x to the 2nd power. Good or not good? By the way, curiosity. The function is even function because any exponent is 4 and 2. When you replace x for negative x, you make a reflection. The function stays the same. And that means that the graph is symmetric with respect to the y-axis. Super good. Super good. I understand very well now. Let's do another example. Example 3. Easy. We are doing now easy example. Probably in a few minutes, I complicated thing. Okay, come back to the whiteboard. Let's do another example. Easy, easy, easy. No hard. Okay. This example 3 can belong to the collection for the easy. Is f of x is equal x to the 6th power minus 3x to the 4th power minus 4x to the 2nd power. Okay, entonces I need help a little bit. Degree of this polynomial. Degree. What is the degree? What is the degree of this polynomial? Tell me. What is the degree? Hey, what is the degree?
6.
6. Very well. Okay, what is the end behavior expression of this polynomial? What is the end behavior expression? Remember, end behavior expression is a dominant. What is the dominant? What is the guy increasing faster or decreasing faster? What is the expression increasing faster? Who wins? And increasing or decreasing? Come on, help me. End behavior expression. Nobody know that? Sure? Wow.
X to the 6th.
Absolutely. Es the monomial que contain higher degree. Do you understand this or no? It's confusing. When you plug it in, when you plug it in here, suppose que I plug it in 2, x equal to 2 to the 6th power is 64. And however, 2 to the 4th power is 16 times 3. You see that x to the 6th power increasing super faster than, and this is the dominant, que es the end behavior expression. Entonces, the end behavior expression, si you want to represent graphically, what is the idea? Is right up, or right down, and left down. So you need to analyze two things. Exponent even, que es 6. And the coefficient is positive because it's positive 1, no? I don't see any negative sign here in the front, no? Entonces, the end behavior representation is right something and left something. Right what? Right up or right down?
Right up, left up.
And left?
Up.
Exactly. Up. Like that. Like a parabola. I don't know exactly what happened at the middle, but this is the end behavior. And in other words, when the x approaches to positive infinity, y approaches to positive infinity. And when the x approaches to negative infinity, y also approaches to positive infinity. Make sense of this idea or no? Good or not good?
Yes.
Excellent.
Good.
Now let's analyze the zeros, the famous zeros of the polynomial, always, and the factors. For doing that, you take the expression and you enforce it to be 0. And you apply your knowledge of factorization, this expression. I can see that the great common factor is x squared. So we have x to the 4th power minus 3, x to the 2nd power minus 4. And it's a trinomial. This is trinomial. And the trinomial, again, we continue factorization. 2 parentheses is x squared, que es the square root of this guy. And the combination is 4 and 1. 4 times 1 is 4. And somehow 4 minus 1 is 3. And the sign is negative and positive. I think no. Why no? Because you see here another differences of the square. And the factorization, I suppose que I break down this in 2. This x square root 4 is 2. Square root 4 is 2 plus or minus. Professor, what is the reason that you don't factorization this? Because the sum of the square is prime expression. And the reason que es prime, you see clear now. Look, entonces I separate in several factors. The first factor is x squared equals 0, que is equivalent to say x equals 0, multiplicity 2. Therefore, touch x-axis. The second is x plus 2 equals 0. When you solve for x, it's negative 2, multiplicity 1. Entonces, cross. X-axis. And third is x minus 2, 0 is x equal positive 2, multiplicity 1 again. Same idea, cross. And this guy gets x squared plus 1 equals 0. So you try to solving, look, surprise. You try using your knowledge in the quadratic formula. X squared equal minus 1 and move 1 to the right hand side like a negative, apply square root both sides. X is equal, and I know by definition the square root of negative 1 is I plus or minus. This is the reason. So the factorization, saying in intermediate algebra, you say, okay, this expression is prime. It's prime because the factorization in the real field is impossible. However, in the complex field, yes, we can do it in this way. XX, II, positive and negative. Let me prove. Let's do a FOIL. You FOIL here to verify everything is okay. FOIL. This and this together is x squared. This and this is minus ix. This and this is plus ix. And this is minus I squared. This is cancel out. It's obvious. And I squared, you know, is negative 1. And negative 1 double is positive x squared plus 1. Entonces, when you're talking about real numbers, you consider that this factor is prime. And somehow it's called irreducible quadratic expression. Irreducible quadratic expression. Leave it like that. See, in the question of the test of the Alex, say, express it like a linear factor, so factor completed, using real and complex. Okay, so we are doing it in this way. But no, for the moment, no important. For a moment, you leave it like that. So let me summarize the idea. What is the zero that we have in our problem? Zeros. Well, zeros is x equals 0, multiplicity 2. Touch. X equal negative 2, multiplicity 1. Cross. X equal positive 2, multiplicity 1. Also cross. And that's it. See, we are talking about real zeros. As you're talking about, you extended the complex or imaginary, que es complex zeros, incluye real and imaginary or complex. Entonces, you listing additional this x equal I and x equal minus I. In this case, when the S complex or imaginary and the real field que we are doing the graph, que es xy, everything is real. And you don't see this complex. It's invisible. Okay, invisible. Let's do it a little bit, the graph. The graph. Okay, the graph. Okay, I saw the end behavior. Well, this is the roughly graph by hand. The zero guy discovered was zero again, similar to the other problem. 1, 2, 0, and negative 2. The end behavior, look, it's like that. Entonces, well, approximately, this is touch, cross. It's similar to the example to except the new situation that bring me. This example is the complex or imaginary factors. Sorry. So you listing the factors here, factors. What is the factor que our polynomial have? X squared. We have x plus 2 factor. We have x minus 2 factor. And we have x squared plus 1. Que this guy is irreducible quadratic expression. Okay. Okay. But you see that this guy in the graph, you don't see. No? Because the previous problem have not this factor. However, the graph is very, very similar. No? Not equal, but very, very similar. But the complex, no, I don't see. Never I see. And the regular xy plane in 2 dimensions, because this axis x and y is real number, no imaginary number. Imaginary living in another dimension. Okay, let's do in Desmos now to understand this. Desmos now. Okay, example 3. Boom. Do you see it's similar? It's similar in with respect to zeros. This peak is too long. But it's not important. And the end behavior, the end behavior and the same measure que the exponent increasing faster. As increasing faster, the rate of change of the graph is almost vertical. No totally vertical, but the inclination is greater. So this increasing faster, super faster, because it's to the 6th power. We respect the example to look at to the 2nd power. No? You see, you compare both. It's the same. However, the blue guy increases faster than the purple color graph. Okay, purple color is example 2. Yeah, purple color. Look, purple color, and this is increasing faster. Any question? Do you understand very well or no? Super good or no? No? Hard? Complicated? Okay.
A little complicated.
Well, sorry, you have to practice. Remember, what is my conception? Okay, you have to study. You have to study doing the homework. You are not alone in the world. You have me. Okay, anytime. A lot of people send me the problem by the screenshot. I solve it immediately. I send to you the answer. I have tutor with me every Wednesday from 11 to 4, 11 a.m. to 4 p.m. And Jose Alegre, que is another assigned tutor, is every day. I don't know, I don't remember very well his schedule, but I have a lot of tutor available anytime. But you have no excuse, you have to study, okay? And this is just the beginning, right? This class is super, super complicated, okay? Well, let's continue. Okay, what is the next topic? Well, the next topic is, well, the problem is that the thing or the method that we are using to compute the zero in the polynomial factorization. But factorization is very, very, very weak. No good. No good. So I need to discover another more efficient way to do that. Actually, in the real life, we are using combination of the method because this is challenging. So now I want to recall long division and synthetic division. Long division, and one version of the long division gets a shortcut, is synthetic division. It's another method we are using to factorization polynomial. Let me recall long division first, and after I want to recall synthetic division gets a shortcut to do fast. I prefer synthetic. Okay, and so far we are doing synthetic, but I want to illustrate it's the same thing. Well, not the same, because long division is using always, anytime. However, synthetic division you use it sometimes, but in a specific case, and when you want to discover factors. Let's do in one example. Suppose I want to divide 2x squared plus 3x minus 14 divided by x minus 2. Okay? Okay.
Professor, we see decimal.
Sorry, carajo. Thank you, miss. Okay, I need to come back to the whiteboard. Thank you. Don't hesitate to say, because I am focusing on the mathematical part. I don't realize in what screen I am. Okay. Now, okay, well, the only thing I explained was long division, synthetic division. Let's do it now. Long division is, you're using that format. Okay, it's 2x squared plus 3x. So you put the expression in the top, okay? Let's call it dividend inside the box, no? And you put expression in the bottom, okay, it's a divisor you put outside the box, no? And you start the division, long division. So you need to find one expression, okay, multiply by x, give me 2x squared. It's obvious it's 2x. Because when you multiply this times this, and after this times this, okay, is 2x times x is 2x squared. Exactly, we need exactly the same of this. And 2x times negative 2 is negative 4x. And remember, division is a procedure in which you multiply and subtract. Multiply systematic. Multiply, subtracting. Multiply, subtracting is division. By subtracting, you change the sign. You put plus. This is cancel out, and this is 7. And stop here or continue? No stop. You keep going. Why? Because you stop when the degree of this expression is smaller, so the degree of this is smaller of the degree of the divisor. In this case, the degree of this expression is 1, and the degree of the divisor is also 1. Therefore, we cannot stop. Okay? Entonces now, okay. Bring down minus 14. No problema. And the expression is 7. No, it's 7 because 7 times x is 7x. And 7 times negative 2 is negative 14. By subtracting, you change the sign and remain the 0. So in conclusion, the answer of this is this answer. This is the answer. Is 7x, 7x no, 2x, sorry, plus 7. And this is super important detail. When the remainder is 0, it's because the factor that you are investigating is x minus 2 belong to the polynomial. So the division is perfect, no remainder. Okay? Therefore, why not? You can write this polynomial like a factorization 2x plus 7 times x minus 2. Sorry, I put back down, but it's the same multiplication. You follow, you come back here. So this is one super efficiency way to do the factorization without factorization, using synthetic division or long division. Let me explain synthetic division. It's the same thing, but super, super, super easy. Okay, we come back again, but synthetic division, wait. You, let me see here. You copy the same format, similar. Now, you copy only the coefficients 2, 3, and 14, and negative 14. The x, no, let's omit. Actually, in my mind, I suppose that this is x to the 0, x to the 1, and x to the second. Sometimes it's important to write this, because in one example, some guy is missing. See, when the word some guy is missing, you put a 0. But in this case, nobody is missing, so it's not super important to write that. And now here you put a divisor, but you put a divisor with the opposite sign. Look at that. This is the factor is x minus 2. You put 2. This avoid to change the sign several times. No, you change the sign one time and that's it. Look, I bring down 2. 2 times 2 is 4. 3 plus 4 is 7. That this bring down without operation, your multiplication, this and this. 2 times 2 is 4, you put here. So in any column after that, you're adding or subtracting dependent sign. This is 7, and now multiplication again. And 14, and the remainder is 0. Wow, fantastic. Synthetic division. I like so much synthetic division. Therefore, I discover that the remainder is 0. I discovered that the remainder is 0. Therefore, the factor x minus 2, opposite sign of this, belong to the polynomial, okay? And why not the 0 que corresponde, this is a factor. This is a factor. The 0 is x equal 2, no? Opposite sign. We have one more factor. Of course, we have one more factor because the degree of the original polynomial is 2, and we discover one factor using synthetic division. What is the next factor? The next factor is that part. Look, that part. Okay, that part is, this is x to the 0, and this is x to the 1. Actually, it's 2x plus 7. And the 0 is, you know, when you put it equal to 0, minus 7 over 2, no? Make sense? Make sense or no? Wow, fantastic. I like that.
It makes sense. Yeah, it makes
Second,
sense.
makes sense, right? A factorization without factorization. In the real life, this is complicated, and we are doing using factorization and synthetic division together. It's more strong than just factorization. Let's practice a little bit synthetic division. Let's practice a little bit synthetic division. Let's practice. Let me see. Let's practice a little bit synthetic division. Curiosity. Another example. Okay. Let me erase. Okay. Suppose to complicate your life. I put in weird way. I put divide this polynomial minus 10 x to the second power plus 2 x to the cubic power minus 5 divided by x minus 4. I forgot to say something. So we can apply synthetic division when you divide any polynomial of the degree something divided by another polynomial of degree 1. So it's possible apply synthetic division when the degree of the divisor is 1. Otherwise, no. You need to apply long division. That is the reason the long division is more general, but it's complicated. So to make shortcut, so when your job is discover the factor of the polynomial, the best way is synthetic division, because I suppose the factor is polynomial of the degree 1. Okay, let's do in synthetic division. Let's do in synthetic division. I don't know see the remainder is 0 or no. I don't know. Let's try. So what is the format for the synthetic division? Look, let me show you. This is the format for the synthetic division. I am totally lost here. One of the degree of this polynomial is 3. To confuse you, I organize a little bit crazy. Okay, but no problem. I understand the higher degree is higher point is 3. And then you put x to the 0, x to the 1, x to the second, and x to the third power. Okay, wow, too long. Let me erase this. It's okay. X to the 0 is negative 5. X to the 1 is missing. It's missing. We have no x to the 1 here. X to the second is 2. And x to the cube is, well, x to the second is 2. And x to the, no, I go, no, a ver, no, coño. It's negative 10. It's negative 10, it's negative 10, x to the second is negative 10, look. Wow, I confused myself. And this is 2. Okay? This is x to the 0, x to the 1 is missing, do not exist. X to the second is this guy, and x to the third is this guy. And the factor here outside is 4, positive, opposite sign to the factor. Bring down 2 without do any operation. A multiplication is 8. Subtraction is negative 2. Multiplication is negative 8. And 0 is negative 8. And this is 32, negative 32. And the answer is negative 37. And this final number is the remainder. If the remainder is not 0, that indicates that this factor x minus 4 don't belong to this polynomial. No? Okay, no problem. Understand. However, how you write the final answer? The final answer is, well, the final answer is this polynomial. This. Always I listing like that. This is x to the 0, x to the 1, x to the second. So the answer is 2. X to the second minus 2x minus 8 minus remainder, que es 37, divided by divisor, que es x minus 4. Well, when the remainder is 0, it's nice, because that part do not exist. That is a reason that this factor belong to the polynomial, but no, in this case, no. Remainder is a number, 37, negative 37. Entonces, the only thing that you should do, if you want, is write the answer of the division using remainder. Sorry, the formula is, look, the formula is this guy, this guy, this guy, this guy, this guy is a quotient. Let me call name quotient. This is the remainder. This is a remainder. Look, and this is divisor. It's similar when you divide 5 divided by 2. In elementary school, you put 2 times 2 is 4, subtracting 1, and this is 2 1.5. The format is, this is a quotient, this is a remainder, 1, this guy, and it's a divisor. In this case, 2 and 2 is a coincidence, but it's just example. No? Do you understand very well? Okay, I promise that we are doing thousands of the synthetic division. And little by little, you understand this. Let's move on to example 4, que es very, very interesting. Example 4 is very, very interesting. Because it's exactly the polynomial okay, we cannot do by factorization because factorization have limitation, and the only thing you should do is doing by synthetic division. Okay, so now as always, let's start. What is the aim behavior expression? Or x cubed. X cubed look like that. So it's right up, left down. Then when we finish, we see something like that. And that part I have no idea. But once you have idea, we need to determine the zeros. Entonces I need to solve in this equation. By factorization, it's impossible. No. Grouping, no. Difference of square, no. GCF, no GCF. Then you are doing synthetic division. But the challenge is discover what is the factors. In the next class, maybe we study some theorem that can help me to understand this a little bit more clear. Okay, to say the question that fly in the air is, well, professor, okay, I understand the synthetic division. Okay. I copy is -6, 11, -6, 1. Okay, good. So the question that fly in the air, well, what number I put here? No idea. Well, in the next test, in the next lecture, you see where I confront this number or potential number. Suppose 1. I'm guessing 1. So I bring down 1. 1 times 1 is 1. -5. -5 times 1 is -5. This is positive 6, and positive 6 times 1 is 6. Wow, fantastic. Remainder 0. That means que the factor x minus 1 belongs to this polynomial. Okay, this is the factor. And the 0 is x equal 1. Everyone follow me? So the problem is, oh, professor, we are confront this one. Okay. I understand that you don't understand very well now. But okay, I know the problem I did before. You. Suppose 2. And you try 1, 2, 3, 4. No. It's another law that we explain maybe next time. So bring down 1. Multiplication is 2. This is -3. Multiplication is 6. -6, sorry, and remainder again is 0. I discover one more time that the factor x minus 2 belongs to the polynomial, okay, or x equal to is the 0, corresponding with the factor. And stop, because the quotient is x to the 0 and x to the 1, que is the factor x minus 3. Okay, it's x minus 3 is the last factor, and x equal 3 is the last 0. So you, for example, in the test say, how many zero and multiplicity we have in this polynomial? Well, the 0 listing is 1, 2, 3. And everything multiplicity 1, no? Multiplicity 1, multiplicity 1, multiplicity. So across it. What about factor? The factorization of this polynomial, well, the factorization is too easy. The factorization of this polynomial is x minus 1, x minus 2, x minus 3. Okay? So now you say, well, okay. I explained in the last class where I come from this 1, 2, 3, 4, 5. However, you are smart guys. And one super fantastic way to do this is You are doing the graph in decimals first. In decimal, you see clear the real zeros. So you are doing the graph. You have no idea. You put in decimal, boom, and you see, wow. And you discover the x intercept. And x intercept is zeros. You see 1, 2. You see now, I want to show you decimal now of this polynomial. You see 1, 2. So you prove me in the piece of paper using synthetic division that this value that you see in decimal work. How do you know it work? When the remainder is 0. When the remainder is 0, this is a factor. Do you understand the idea? No?
Yes. Yes.
Okay, okay, good. Okay, let's go to decimals to see this example. So in the real life, we can do it in that way. You have the polynomial in the test. Okay. You are doing the graph of this polynomial. Look. And you can see at what point my polynomial crosses or touch the x-axis. In this case, 1, 2, 3. And you come back to the paper and you perform, I did scientific division using 1 first and 2 second. But the order is not important. So you are doing scientific division using 3 first and 2 second or 1 second, you get the same answer, right? Because when you see that the remainder is 0, is because this factor that you try belong to the original polynomial. Super clear or super confusing? Let's see what is the next. This is 5. Okay, this is 5. Let me see what's 5. Yes. Okay. Okay. Let's try. Okay. Do you understand decimals? Switching. We come back now to the whiteboard. Okay. One more example. Do you see whiteboard?
Yes.
Yes.
Okay.
Yes. Yes.
One more example. I promise to push in a little bit more clear. In the next lecture, we study some theorem that can help me, not only decimals. So when you have no technology, the mathematicians, the antique mathematicians that have no internet, we have no graphic calculator, using another technique, we study this. But we are living in 21st century, the United States of America, and we have internet, we have all possibility to analyze. There are no reason. Okay? Because now, let's do in this polynomial. This is example 1, number 5, no?
Yes.
Yes.
Is f of x is equal to x cubed minus 3x squared minus 11x plus 6. Okay, let's do in Bauer. I am lost, completely lost. I put in decimals, and then I can see using my eyes, no mathematical, only what is the potential zeros, real zero, because the imaginary, remember, is invisible. And you try, prove me in the piece of paper, okay, this is good. Let's do it. We come back now to decimals. I suppose you see this one right now, right? Look, this is my polynomial. 2x cubed minus 3x squared minus 11x plus 6. Okay. I did that. Boom. Wow. Look at that. Look at that. Oh, yes. Entonces, I copy in my piece of paper. I see look at the aim behavior, but this is not important now. I focus it in the zeros. In the 0, I saw we have 1 0 and 3. We have 1 0 and negative 2, and we have 1 0 and positive 0 0.5, que es 1/2. Ajá, ok, entonces I go directly to the piece of paper and I try several synthetic division using this value. Let's do it. I copy 2, -3, -11, and 6. Ajá, entonces it doesn't matter the order. Suppose que I select 3.
Professor, the screen is still on the
Ah, yeah. Now, it's okay?
Yes.
Okay, entonces the factor que I see in Desmos, I see in Desmos 3, -2, and 0.5, que es 1/2. Entonces, it doesn't matter what you want to start. 3, suppose. Bring down 2. This is 6. This is 3. This is 9. This is -2. This is -6. 0. Wow, fantastic. I like that. Therefore, the factor x minus 3. This is the factor. And this is the 0. Belong to the polynomial. Let's try -2. Bring down 2. Is -4. Is -1. Is +2. 0. Wow, fantastic. The factor x plus 2. Look, it's important. Que the number that you put in the synthetic division is a 0. Sorry, I make a mistake here. This is 3, no? +3, and this is -2. Okay, the number you put here in the synthetic division is the 0, and the factor is the opposite side. You know that, right? And the last is the quotient is x to the 0, x to the 1. Actually, the last factor is 2x minus 1, no? And the 0 is +1/2 because 2x minus 1 equal to 0. You solve for x. 2x equal 1 divided by 2. It's obvious que es 1/2. Make sense? Do you understand the idea? Do you understand? Entonces, wait. Suppose que in the test I ask you, factorization this. Okay. What is the factorization? Well, the factorization is professor, x minus 3, x plus 2, and 2x minus 1. End the story. What are the zeros of this polynomial? Well, is 3, -2, 1/2. Super clear?
Yes, bro.
Excellent. Beautiful. Now let's do it one more and that's it. Another example, number 6. Okay, entonces number 6 is, let me check it out. In Desmo, see my paper and Desmo coincide perfectly or no. Let me see. Oh, yes. Good, very good. Okay. Suppose. Okay, erase the board. Erase, right? Yes.
Yes.
Example 6, no?
Yes.
In the example 6, we have another polynomial. Okay, it is x cubed minus 7x squared plus 15 x minus 9. Okay, let's try to summarize everything we are learning today in this example. No? Okay, what is the degree of this polynomial? Please help me.
3.
What is the end behavior expression in this polynomial?
X cubed.
Excellent. How look like this? Right up, right left, left down. I am lost. Right, left, RL, right? In what direction? Remember, the exponent is
right up, left down.
Left down. Very good. And another way is when the x approaches to positive infinity, y approaches to positive infinity. Up. This is right. This is up. When the x approaches to negative infinity, this is left. Y approaches to negative infinity. It's down. To see more clear graphically, it's something like that. This is the end behavior. Any questions so far? Well, now where's the next? Well, the next is the zeros. To find the zeros, you take the polynomial and you enforce it to be 0. Okay, let me take advantage of this boredom moment to see. This is what is the formula that we're using always to find x in a set? Well, the formula is the function equal to 0. Okay, it's easy to remember because basically the thing that we are doing is enforcing y equals 0. And the y in a set formula is evaluate the function in 0 because you enforce the x equals 0. And you get the number here, and this number represents the y in a set. Okay, by the way, in this case, it's -9. Okay, in this case, it's -9. Therefore, the famous y in a set is at the point 0, -9. But this is easy because it's just plugging in. The complicated part is find the x in a set, que es the zeros, right? Let's do it. Scientific division, pero I'm lost. I don't know how to start because I go to decimals. Decimal is my friend. Okay, help me to do this. Okay, I have no idea. I'm lost, completely lost. However, I go to decimals. Okay, decimals now. Here. Okay, do you see right?
Yes, Profe.
Example 7 now. Wait, no 6. 6. Sorry. Wow. Help me, guy. What zero you see? Let me copy the piece of paper. What zero you see? I'm waiting for you. What zero you see? Okay. Our polynomial is degree 3. We expect 3 zeros. Well, no, always. Maybe it's complex. You don't see here in the graph, But in this case, I see how many zeros you see in the graph. How many? How many points?
2.
2 and 1 in positive 3, correct?
Yes.
However, the behavior is different. The behavior is in 1 crossed and 3 touch. Yes or no?
Yes.
So what happened with the multiplicity? Well, I know that when the multiplicity is even, is touch, no?
It touches.
Entonces, I suppose, using my imagination, que we have one factor in x minus 1, que es in the point 1. Yes, the factor is x minus 1. And we have 2 more factors, or 1 more factor, is x minus 3, but raised to the second power. Make sense, right? Because the multiplicity is 2. Make sense or no? Make sense or no? Do you understand this idea or no? Hey.
Yes.
Okay, let's try it now. Okay, entonces 1 and 3. Entonces you are doing scientific division using 1 and 3. Doesn't matter the order. The order is not important. All right, let's do it. Synthetic division using the factor I see in Desmos. I see in Desmos something like that. This is 1, this is -7, this is 15, and this is -9. I'm using maybe 1. Why not? Or 3. Bring down 1. 1 times 1 is 1. This is -6. Multiplication is -6. Is positive 9. Is positive 9. Remains 0. I prove mathematically that x minus 1 is a factor. And the 0 are x equal 1. Now I try 3. Get the other guys. Well, bring down 1. Multiplication is 3. This is -3, and -3 and 3 is -9. Wow, it's 0 again. Beautiful. X minus 3 is another 0. In the quotient I can see x to the 0, x to the 1. When you convert to the factor, it's x minus 3. Entonces you see que es repeated. Multiplicity 2. Entonces si you say, well, what is factorization, professor, of this polynomial? Well, is f of x is equal x minus 1 times x minus 3 times itself, and it's more comfortable to write square. And what is the zeros? The listing 0 of this polynomial is x equal 1, multiplicity 1, cross the axis, and x equal 3, multiplicity 2, and touch the axis. Fantastic. Yes or no?
Yes, Profe.
Okay. We have time to another problem? Yes, why not? Let's do another problem, yes. And that's it. I promise. One more, number 7, and that's it. Okay, we need to practice, guys. Synthetic division. Do you understand the idea? Do you see before in high school or no? You see before synthetic division in the high school? Everyone?
No.
Huh?
No.
Never. But
Never.
you take high school in Miami, in United States of America, or no?
Yes.
And you never see synthetic division in the high school?
No.
Wow. What high school you assisted?
I think it was. I'm not.
No, it's okay. I don't care. It's a job. Okay, you see with me now. Super. You understand very well or no?
Yes.
Okay, so this is important. Let me check in the next problem in this most a coincidence exactly with the I have in the paper. Yes, it's exactly. Okay. Next problem, number 7 is. Do you see whiteboard? No? Yes or no?
Yes.
Example 7. F of x is equal. This is 2 x to the cubic power minus 3 x squared minus 11x plus 6. Okay, so fantastic. Okay, again happen que degree is 3. The unbehavable expression is 2x cubic. Okay. One more unbehavable expression. I suppose que our graph look like that. Yes or no? Is right up and left down. Okay, this is easy. Let's focus in the zeros, que es the complicated part. Okay, entonces I go to Desmos to investigate something, and you help me to see that. Look. Okay. Desmos, switching, Desmos. Okay, good. Okay, here you go. Okay, I put expression. Boom, I do the graph. Okay, and behavior, I don't care. I care only the 0. I focus my attention in this 0. What 0 you see? Help me. What zero you see? What zero you see? Help me.
-2.
Negative 2. Who more?
5 and 3.
5, no. 0.5.
0.5.
0.5 is 1/2, no?
I'm sorry.
No, it's okay. It's okay. Unfortunately, in Desmos, let me see it's possible fraction or no. 1/2. 1/2. 1/2. No, I put 1/2. However, in the graphic 0.5. It's the same. So I copy my piece of paper. The 0 is -2, is 1/2, is 3. Okay. But I need to prove to the professor in the test by hand in the piece of paper. And the professor explained me synthetic division. Okay, so I create the format for the synthetic division. Not good. 2, -3, -11, and 6. As I saw in Desmos, I saw -2, 1/2, and 3. What do you recommend me do? The order is not important. You are doing, even the fraction is perfect doing. But okay, to make easy the problem, no? Let's doing, I suppose, 3, que es positive, no? Yes or no?
Professor, you're still in Desmos.
Ahí. I forgot, always. Now you see?
Yes.
Okay, the thing I try to explain is que in Desmo, I see this, right? And we start doing synthetic division. What order you recommend me? I select 3. It's okay or no? Or you prefer -2, or you prefer 1/2? 3 is okay?
3.
One of the reasons is because it's whole number, no fraction. And it's positive. Okay, let's do it. Bring down to multiplication. 2 times 3 is 6. This is positive 3. 3 times 3 is 9. -2 is a -6. 0 remainder. Okay, therefore, the factor is x minus 2. And the 0 is x equal 3. One more after. -2 or 1/2? What do you think? It's better. -2.
-2.
Bring down 2 is -4, is -1, is +2. 0 remainder. So when you see 0 remainder, I am happy. Or why no? I am sad. Because this factor belongs to the polynomial. That's x plus 2. Remember, very important. So you are doing the factorization, the synthetic division using -2. The factor is opposite sign. And the 0, no. The 0 is the same sign. And finally, you need to continue synthetic division. No. Why no? You stop here because this is a linear factor. This is x to the 0. This is x to the 1. Actually, this factor is 2x minus 1. Is 2x minus 1, que by the way is 1/2 positive, no? Because 2x minus 1 equals 0, 2x equals 1 divided by 2, it's obvious que it's 1/2, right? So what is the final answer? Well, the final answer is the factorization of this polynomial. You copy the 3 factors, this, and this. It doesn't matter. The order is not important because the multiplication, for example, I copy in this completely weird order. Yeah, I guarantee you 100% because when you FOIL this, you expand this, you come back to this. This is a fantastic idea without the regular way to the factorization that we study in elementary algebra. And the list of the 0 is 3 positive, -2, and +1/2. End the story. Guys, too much. Remember, everyone, today is the last day to submit the test online in Alex. And also send me by email the answer and details, show me your work of the written test, okay? Because tomorrow in the morning I start grading this. Yeah, I posted, you see your score in Blackboard. And remember, sorry, I forgot to say something. Please, when you send me the test, try to send me a copy of the subscribe in my YouTube channel. Bueno, the student can subscribe, no, it's not mandatory, but remember the 5 point extra in any reading test. 5 point. Yes. No, because I try to see my YouTube channel, but it's complicated. It's not clear. What is the subscribe people? No, entonces different name. No, you send me attached with the reading test. You subscribe, I put in the grade book, and that's it. Any other question? No.